was impressive because I mean, really, if I understood, means that it was really spot on. So something, not everything, but something I think. So, yeah. So yeah, I am the CEO of the company and founder of SmartCoach Europe, SmartCoach Technology. To second history, so it all started in 2004 when I moved to Sweden. The logo, of course, the Sweden logo of Sweden, and I was working for the European Space Agency with the inventor of flight technology from which the K-box and other come from. And back in the days, there was a need for something to monitor flyaway machines for use initially in space, but then, of course, flyaway have been used in sports, and we have been working with the first guys that have been using flyaway technology in sports, and there was the need for transfer to from science to the applied sports in which, of course, you don't have time. Time is a precious resource. If I understood from Sebastian's presentation, time is a major constraint when you're doing testing. So we say that you cannot improve. Well, Lord Kelvin said that you cannot improve what you cannot measure, which is obvious. But if you don't have time to measure, you don't do it. So, or if it takes too much time, you don't do it. So the idea of testing should be an additional tool for you, not an additional task or burden. Okay, so we start developing the SmartCoach system to work initially with flywheel, which at the time was innovative, and weights, and then as we enter into the field of professional sport, we came to know other realities, machines, and more people by popular demand were asking about to make the system compatible with Kaiser's machine, which is the reason why we are also here now. So the spin-off of this research project became a company, and now we have the company is registered in Sweden and in California, and together with Shailesh, with the CEO of the company, we have production in India. We have 2 research laboratories, one in Mumbai, one in Turin, and we are working pretty much in Europe, but also I would say at a worldwide level. So now I'm going to make a first part in which I'm going to discuss some theoretical aspects of physics applied to resistance training, which is going to then connect to what is the purpose of smart coaching point we are here now today. So what I'm going to discuss comes from this book, which in part from some research which we have been doing. So theoretically, the concept that all of our products are based on science and validated. It's one of the concepts that I also kind of understood that we were underlining. So this is the editor of this book is our internal sport scientist, Alejandro, and I wrote the first chapter in which I took this. Okay, so a quick excerpt about the physics of resistance training. So because we have weights, we have flyaway machines, we have Kaiser machines, and I would like to go quickly through what's the meaning, why one system rather than the other, etc. What the difference, what the things in common. So very quickly, without being too boring, I am an engineer, so I am too fast. So in weights, okay, some people say weight training is isotonic, constant force. That's not entirely true, because it all boils down to physics. There are 2-3 laws of physics that regulate everything that we are using in the day. Okay, so in this case, the law of Newton, force is times mass times acceleration. So when we lift weights, we have the gravity acceleration and we have the acceleration over the movement itself. So when we train slow, this acceleration of our movement is very low compared to the gravity acceleration. So the weight component is almost predominant and the inertial force is almost absent. So we train slow, the force is fairly constant, isotonic, but as we train faster, that's not true anymore. So if you want to measure, we need to know what are we measuring and how the device that we are using work, because that's the only way to understand the results in the application. So weights, they are fairly constant force as far as we train very slow, but as we train very fast, the weight is not constant force anymore. This potential component can become more and more, predominant until it is even more than the weight. For example, plyometry is one exercise with weight. You use your body weight and it's not at all isotonic, not at all constant force. So that's one device. Now, the same law of Newton, force times acceleration, it applies also for flywheel devices. A different movement is not linear, it's rotational. In this case, we don't have the gravitational component, it's just pure acceleration. So this device, for example, the force is completely variable. And if you don't have a system to measure what you're doing with flywheel, you have no idea what is the force. So you cannot even say that the same inertia is the same load, because it depends on how you execute. On weights, you can say 30 kilos is equal to 20 kilos, okay? But with flywheel, the same flywheel, you can train with your finger with the maximum force, the same flywheel give a completely different force. And just to mention one aspect, not to mention if you want to enter into eccentric overload, okay, which I don't want to enter too much in detail, but if you don't measure it, you have no idea, you don't know if you're exploiting it, using eccentric overload. Now, and that's a comparison. Weight, that's real force curves from weights versus flywheel. Force fairly constant for weights, completely variable flywheel, okay? Completely different physics. I will skip the eccentric overload, but very briefly, some devices can elicit eccentric overload depending on the execution, okay? Of course, you need to, if you want to exploit that feature of the machine, you need to measure, otherwise you have no idea. Flywheel machine can become even dangerous if you don't know what is the degree of eccentric overload, or they don't give you eccentric overload at all if you don't see it properly, if you don't have a feedback that tells you what you're doing. And then Kaiser machines, which are a great invention. So by the way, very quickly, while I was working with the European Space Agency, flywheel were the solution implemented by the European Space Agency to train astronauts in space. The space model of flywheel device on board the space station has been built in Germany, in Bremen, by the way. And while the European Space Agency was using flywheel to train astronauts, NASA was taking inspiration from Kaiser machine. They built what is called the IRA device, in which uses a completely different principle. It's another physical principle, which again is physics from high school, okay? In which instead of having mass to create force, there is pressure to create force. Why so? Because force is pressure times times the area of the cylinder. Constant pressure, the cylinder is same, constant force, constant area, constant force. Simple, brilliant, and there is no mass. So in this case, that's exactly why Kaiser machines say you can train fast, because there is no mass, which multiplied by acceleration will give the inertial force that opposes to the movement. And that's an example of to compute force on a cylinder. I just don't get into detail, but for example, just take the measurement of that cylinder of the leg press, put it there, you can create forces of hundreds of kilograms without having the need for hundreds of kilograms. Now, we don't care about that because it's just a bit of the machine. But in space also this was an issue because you can embark a machine in space without spending too much fuel by launching that into orbit. It doesn't matter its detail. I skip comparison weight versus flywheel. It's another typical graph that is being shown when somebody considers Kaizen machine in which if you train slow, then pretty much the two machines they are equivalent, but if you train fast, what happens is that at the beginning of the movement, when you accelerate, the mass, the weight has an inertial force which adds to the weight and creates an initial force which opposes the movement and doesn't allow it to work faster and vice versa. Now, I'm not here to sell Kaizen machines or flywheel machines or weight machines. SmartCoach mission is to measure, okay? But to measure, we need to understand the physics of the devices. And one aspect that I think you grasped already is that three machines, they work on completely different concepts. And if we mention also rubber bands or spring-loaded machine, NPP Shuttle, Raptor, Vertimax, etc., another different physics which I didn't even mention. So which means that measuring something in an environment where different tools, different brands is a mess. So the problem is not acquiring data. Actually, one problem that I think Sebastian was mentioning is that you get even too much data nowadays. It's really very easy to acquire data. You can acquire data from, well, not this, but from the old Kaiser display. Maybe it's not too practical, but there's a system to measure. There's an app from APOS. There is a lot of systems for weights, GymAware, Tendo, Muscle Lab, etc. The problem is that we have so much data and so little time, especially if you work with elite athletes. You cannot spend too much time in measuring, and then you end up not being able to measure your athletes, which is the number one need when you're working within sports. So that's where we like to contribute with our ideas. So this is SmartCoach Pro, which is a system which we have been developing, working closely with some of the best clubs in Europe. 1/3 of the clubs that each year compete in Champions League are customers in football. You're going to see that later, okay? The point is that each manufacturer, they hope and they wish that the customer only use one system, but as you can see, in this reality, but everywhere, there are so many brands, so different devices, okay, which is practically impossible, okay, to use different systems, okay. Only with Flywheel, there are like 20 brands of Flywheel devices. Kaiser is on one at the moment. Weights, there are a lot of solutions, but so there is a number of brands, number of different devices, it's which you will require one specific system for everything, for each one, and that is a pain. Now, a typical example here, you have a gym in which you have some Kaiser machine, different types. You have some flywheel machines, you have some weights, okay, and you want to measure all of them. Well, what we have been developing with the SmartCoach Pro is a system that can connect to each and every of these devices. So the same system to measure everything. So that's the gym, and you have a number of computers where you can make the planning. Okay, Sebastian was showing a nice graph in which you do the planning, you do the training, and then the results of the training go back to the planning. Then you find that the circuit is a closed chain, and that's exactly what we do. So, as a quick reminder of the structure of the SmartCoach Pro system, we have one central data collection system. Okay, so one system only, not many, one software only. You have 1, 2, 3 computers where you can do planning, analysis, and each and every machine that you want to monitor is equipped with the bolt part, this screen, which is not just a screen. It's Inside, it contains an acquisition unit which connects to Kaiser machine, connects to flywheel, and also if you want to use with weights, there is an external device that you can use with weights and also with rubber band devices. So that's the idea. One software to do everything, and also there is another problem which I think I overall, if I was not mistaken, that testing takes time, and there was a saying that you say test what you train what you test or testing it. So ideally, you would like to use the same setup for testing and training, because that's in the situation in which the athletes are working. To the point that usually you train repetitions in the pitch, don't have repetition. Every move is different than the other. Maybe you are measuring with isokinetic machines, but for testing, but for training, you're not using isokinetic machines. So there is this conundrum in which training and testing seem to be two different worlds, okay? And it's complicated. Also, planning is complicated because if you work with individual athletes, maybe not much. But if you work with a team, you have to plan one testing session for all the players. Maybe that day some players don't do well, you have to repeat the test. If you work with women, it's even more of a mess because performance already goes through the menstrual cycle with the variation of plus minus 10-15% in due to hormones, which leads to the minimum significant change that you were mentioning. So huge difference, huge mess in planning. So the best would be to have a system that can be used for testing and for training at the same time, which is exactly one of the features that some of our customers like about SmartCoach. It's quick, easy, it doesn't require setting up, so you can do testing, okay? You can do force velocity curves, etc., but you don't have to. The idea is that you can plan some exercises, you can record exercises left and right, or for example, in machines like the Kaiser leg press, in which you have two cylinders, you can exercise left and right at the same time. That's an exercise, it's not a test, okay? But the data can also be used to do an imbalance test without specifically doing an imbalance test, without planning an imbalance test. So it's what a lot of strength coaches which work in Bulbo say. I like it because it's a testing without testing. It doesn't waste time, and it also it's more natural for the athletes in which they feel that they are being controlled, but not in a test in which they might want to perform a different way. So they perform as they would do normally in the gym. The difference is that normally in the gym you train, now you train, and in the background SmartCoach is collecting data which you use, but it doesn't require you to waste more time than is okay. Huh? Okay, so I could get that later. Okay, so there is to identify the athlete. You can choose from a user, or you can also use wristbands to identify the athlete. So pretty much during the training session, the athlete taps the wristband, and automatically is recognizing the system. The system gives a feedback to guide the athlete during the exercise, and at the same time it is recorded for analysis, for future analysis. It can work with Kaizen machine, any Kaizen machine, functional line, so functional trainer, performance trainer, all of the Kaizen machine, the racks also. It can work with flywheel devices. This is ours, it's going to be ours, but it can be any brand actually. The major brands of flywheel devices, they are compatible with SmartCoach. Can work with weight stack machines, and can work with free weights. There is an encoder which we connect to the system, which measures the lifting speed of free weights, and that's the beauty. One system fits all. So weights, flywheel, Kaiser, flywheel, three different systems, the same exercise, sport, but with complete different type of resistance, physics, feelings. In this case, we are using pressure. In this case, we are using mass. In this case, we are using inertia. different units, but all in the same system with the same metrics, the same graphic. You compare one versus the other. For example, you were mentioning among the parameters the work. That also is the same. You can measure the work done. Okay, so if you cannot compare speed with speed, maybe you can compare total work, number of joules or watts. Okay, and all in the same. Now, so maybe. That's the only system. I don't want to show the entire video, but here, for example, you can see that the strength coach is not even in the video. It doesn't mean that the players are training alone, but it means that it's so easy that the strength coach during the training session is not there to work on the computer. It's there to watch what the athletes are doing, which is exactly its purpose is. So you focus on the athletes, not on the software. And you can see several athletes can work at the same time. So there is one more video. This is more specific to what I'm going to see because it's more targeted to Kaiser because the system works with any system, with any brand, but it is very optimized with Kaiser because of the features of this machine. The fact that you can change the load in real time, which you cannot change in any other type of machine. The fact that you can measure left and right simultaneously with two different speeds. This machine, that machine, the runner, make this conjoint perfect. Especially, for example, the leg press, with a reasonable budget, you have a machine which is perfect for training, training also fast, but also for testing, because now you can measure the left and right force at the same time, and then you can measure the imbalance, for example. So this is a bit more specific.
Welcome to the future of performance assessment and training integration with SmartCoach. Get ready to revolutionize your workout and rehab experience. The Bolt Pad is a complete transformation of your training sessions. With the cutting-edge features, it takes your training to the next level. Experience 3 dynamic modes. The Kaiser mode for all standard measurements. The Kaiser Quick Measure mode, offering you the flexibility to select exercises and rest timers. And the SmartCoach Pro mode, your gateway to advanced testing and training techniques. Measure left and right differences. Graphs can serve as powerful visual aids to track and compare the progress of your left and right legs over time. Say hello to hassle-free athlete recognition with the SmartCoach wristband. A simple tap and your custom training program is at your fingertips. Multiple athletes can switch easily between machines with the wristband, ideal for circuit training. Craft custom training schedules based on your individual needs. The SmartCoach Pad adapts to you, ensuring every session counts. Train smarter with real-time feedback. The color-coded bars, green for okay, red for too high, and blue for too low are your guide towards perfect performance. Tailor your workouts for maximum efficiency and results. The Bolt Pad from SmartCoach on Kaiser machines is your ultimate training companion, guiding you towards your fitness goals with precision and innovation. Elevate your workout, transform your results. Discover your optimal load with the Power Test feature. Experience centralized data collection like never before. After your training, dive into detailed graphs and raw data on your computer, fine-tuning your progress.
So, just a few more slides on that. So, okay, so that's the part, okay, it works with the, what's that? Let me just, okay. So that video summarizes all these slides and maybe, more synthesized manner, okay? Because at the end, that we're gonna play with it. So I just want to briefly mention what you can get. So this is what has been shown in the video already. I just want to. Yes. Yeah. So yeah. I have everything. So I was about to stop on this one. So this is one of the feedback windows, okay, in which once you're trained, you get an instantaneous snapshot of what you're doing. Each bar represents a repetition. You can have only the concentric phase, the concentric phase. You can set a target. Okay. It was selected, right? I didn't see from this angle, so I didn't ask him. Okay, we won't touch that anymore. So. You can have the option of additional views. For example, this is the raw data to show this represents an average of the entire repetition, but with this graph you can see if the execution, the form of the repetition is good. Of course, this is a bit too complex for the user to understand, but it's for the strength coach of the therapist to check the execution. The speed is the speed, okay? The speed is constant, smooth, or jerky. For example, if you have an injured subject, he will show if at specific angles you are not executing correctly. So it will give you objective aid in improving the way of execution. And this is a simple velocity-based training feedback in which the software is measuring the first repetitions and you use the first repetitions as a benchmark. So in this case, for example, was the first 3 repetitions. After 3 repetitions, you get an horizontal bar, which represents your target, which is the best of the 3 initial repetitions, in which you're supposed not fatigue. And then there are 2 lines which represent the tolerance that you want to introduce in those training. For example, plus minus 10%. And in this case, if you exceed the top threshold, the bars will be in red. In theory, if you're executing correctly in velocity-based training, this should not happen because in theory the first repetition is maximum. And then as the power, the speed decreases due to fatigue, the bar will eventually go below the minimum threshold, indicated in blue. When this happens, it means that you have reached the empty zone in which the speed has decreased beyond the maximum acceptable level, and that's where you stop the exercise, not based on the repetition, but based on how much fatigue, okay? Because which we take into account day-to-day variability in execution, etc. So this is a real-time feedback to achieve what you want from your athletes. It can be on velocity-based training, it can be on eccentric overload. In that case, you tell that you want 20% of overload, the bar will be green if you achieve that overload, right? Too much overload, blue, too little overload. So yeah, that's a very simple setting, okay? But if you just have some empty slides in between, yeah. So also the system can work with international units or can use embedded units because they're custom in the US also using the system. You have the option, some options to even choose the exercise. You can track which exercise, not just which athlete, but also which exercise he's doing, he or she is doing. And when it comes to analysis, The software, which is connected to the central database, it has one very sophisticated planner that allows you to choose sets, reps, which target, which phase you want to control, the concentric phase, eccentric phase, and a lot of options to work on the service training, work on the power curve of the athlete, etc. This is an example of feedback in which you have both the concentric and eccentric phase. All of the options are available. This is the analysis panel in which you can track the improvement over time. There is no need to do any analysis. 1 second after the exercise is finished, you can go there and you can see all of the exercises done by the athlete, weights, Kaiser, flywheel, and you can see the progression over time. This is power, speed, load, inertia, displacement. So you can see it's not training if it's the subject is increasing, decreasing. Then, or you can open a specific set and also dig into each specific repetition. This is not enough. You need to do some very in-depth testing. You can go down to the raw data and check each single millisecond of execution. So this test, the imbalance test, is a perfect example of testing without testing, in which you do exercises and the data from the actual exercise are used to do this report without need for a specific session for imbalance testing. Force velocity curves, in which you have the power versus speed and power versus load. This will tell you, for example, what is the optimal training load or the optimal execution speed. And you can use that as the reference, a benchmark to do your plan, closing the circuit that Sebastian was mentioning. So, training, testing, closing. And if there is any need to go such in detail to even check each individual repetition, you can even go to raw data to check what is happening every single millisecond. For example, because of spike of force or execution not done properly, you can also check that. You don't need to, but you can if you need. And it's also specifically optimized for machine, for example, racks, the Kaiser racks. You can combine weight plus pneumatic training, and the software is also optimized for that because it allows you to tell what is the load in weight, in mass, what is the load in pressure, which are two different physics as we've seen before, and the calculation is correct also. Air load, weight load. You can also export data to Excel, or you can connect to the most popular EMS software like SmartCoach, for example. And for weights, we have this dedicated encoder, which is there. Is like others. In addition, you can measure the angle of the wire, not only on the sagittal plane but also the frontal plane. So it calculates correctly, even regardless of the execution. And to finish, there are more than 60 scientific papers which use SmartCoach. They are all peer-reviewed articles. They are not popular science, and they are all used as JCR papers, so they have a good impact factor. Some of them we are co-authors, so there is validation behind that. And of course, we have been working with some good soccer team. Here we are looking at football, okay, football. And we have been working also with other sports, with the NFL, with the NBA, so that it's not specific for one sport only. We have been working with the Olympic training centers, several of them, that's in Colombia, but there's in Spain, etc. And Olympic athletes. All of these are gold winners. Maria Belmonte, there is a video of coach using SmartCoach. Giuliana Razzoli in ski, since we are here in this location. Josefa Iden, which was born in Germany, but now she's Italian. So sorry for that. and Carolina Marin, and other sport, tennis, speed skiing. This should be Valentina Gregis, is another one, but still it's. Dankeschön for your presence, and these are our references. Thank you so much.